Okay, in today's class we are going to see about binary expression trees. Okay, so basically what are these expression trees are? You have learnt already in stack. You have learnt about infix expression, prefix expression, and postfix expression. Okay, so we have there are evaluation of postfix expression and conversion of infix to postfix. So all these things you have seen. Okay, so expression is nothing but it is a combination of you have variables, constants, operators, symbol. Okay, so all these are arranged in a particular manner using some kind of rules. Okay, suppose if it is an infix, you put the operator in between the operands. That is, if you see in this expression you have a into b, so here you have this symbol asterisk in between a and b, which is infix. Some operator is in between, that you call it to be an infix expression. And postfix means after. What is post? After. So if you have an operator after an operand a b plus or a b multiplication, in that case you call it to be a postfix expression. Okay, and a prefix expression is nothing but you have the operator before. Okay, so you have plus ab or minus ab, so you have the operator at before and followed by the operands. Okay, so that you call it to be an expression using some sort of rules, whether it can be infix, postfix, or prefix. Okay, so here in this expression you can see this as an infix expression, whereas you can see the operators in between the operands. All right, so how are we going to express this particular expression in the form of a tree? Okay, so that is only we are going to see in this topic, which you call it to be binary expression tree. So how are you going to express this particular equation in the tree format? Okay, so that you are going to see. So we have to follow certain set of rules in this particular problem, how we are going to solve this problem. So before that we have to see about the precedence. Precedence means the importance, how much importance we have to give to which particular operator. Okay, so suppose if you have for example power of is the highest precedence. Okay, so this have to be given the highest precedence. So next would be your multiplication and division. So this is the next high precedence after this power of. Okay, so whenever you have this power of symbol, you have to traverse this particular equation from right to left. This you have to follow when you are going to express the equation in the form of trees. Okay, if you have a precedence symbol, if you find anywhere from the if you find this particular symbol anywhere in the equation, you have to traverse from right to left. If you don't have this symbol, you have only multiplication and division symbol, in that case you have to traverse this equation from left to right. Okay, and the next precedence is plus and minus. Okay, so this has got the lowest precedence. So even if you find operators like this, you have to traverse the equation from left to right. So following this set of rules only, you are going to solve this particular equation, like how we are going to express this particular equation using the in a tree format. Okay, so we will move, and we have one more thing you have to remember when you are going to solve this binary expression trees. So usually your operands, okay, what are your operands? A, B, C, E, F, all these are operands, and operators are the symbols. Plus, minus, multiplication, division are all your operators. So operands have to be stored at the leaves of the tree. Okay, what are leaves of the tree? The end nodes. Okay, those are called as the leaves of the tree. So always when you are going to express this in a binary tree format, when you are going to express the expression, all the operands will be stored at the leaves, whereas all the operators will be stored at the intermediate nodes. Okay, so what is an intermediate node? Suppose you have plus A and B. So the operators are the intermediate nodes. It has to be stored here, and the operands will be at the leaf nodes. So this will be the format of the tree when you are expressing the expression. Okay, so now we will move to solve this particular problem. So already according to this particular rule, all the operands have to be stored at the leaf. Suppose we take A into B. Okay, so in this A into B, then means if when you are expressing, you have A, B. So this particular part can be explained like this, A and B. So next you have to move. So if you are considering all the operands at the leaf, so your tree will grow from leaf to root node. So you have to find out what will be at the root first. Okay, when you are considering all the operands in this equation or in the expression at the leaves means, so operators will be at the intermediate nodes. So you have to find out which such operator can fit at the root of the tree. So from root of the tree only we are going to derive the complete tree. Alright, so the concept here is when all your operands are at the leaf at the end of the tree, you have to think forward and see which will be the root of the tree, so that from there you have to keep building the tree. So understood till this? So we will move on how we are going to build the tree for this particular expression. So I am writing the expression again. This is just an explanation, so I will write back this expression again so that we can derive it. Okay, or else we will find out from this particular expression which is the root, which operator we are going to consider as the root. Okay, so first you have to see the lowest precedence. When you're going to start from the highest precedence are going to come towards the leaves. Okay, so logically if you see, when you are going to have the highest precedence A into B, next this have to build like this. Okay, it has to be moved. So when all the highest precedence are going to come towards the end, so obviously at the root you have to start with the lowest precedence. So that is the rule. Okay, so how we are going to express this expression using a binary tree is, the first step is you have to find the lowest precedence to fit the root. So when you find the lowest precedence, from there when you are deriving, all the highest precedence will be at the leaf of the tree. Okay, so this is the first step you have to do it. You have to always remember this step. You have to find the lowest precedence first and fit it at the root. From there we are going to derive the expression. Alright, so now it's time for us to find the lowest precedence. So the lowest precedence is going to be plus or minus. That will be the lowest precedence, and when you have this plus or minus in your expression, you have to start traversing from left to right. Okay, so we will traverse from left to right because our expression consists of plus and minus, both plus and minus. If you have only plus also, then you have to consider from left to right. If you have only minus, even then you have to considering traversal from left to right. Okay, so when you are traversing from left to right, you have to find out which is the lowest precedence. So you have one plus here, you have one plus here, and you have one minus here. So when you are evaluating, you are going to evaluate this plus first. Okay, we are seeing only the lowest precedence operator, so we are going to consider in this step, we are considering only plus and minus. So we have 2 plus and 1 minus. So when you are evaluating, you will evaluate this plus first, next this plus, and you will evaluate this minus to be the last. Okay, so we will consider this minus to be the lowest precedence. Plus and minus have both the same precedence. Okay, if suppose instead of plus you have minus here, minus plus and plus if you have, then you have to consider plus, because this particular space only you are going to evaluate at the last. Okay, so here in this particular equation we have plus 1 plus here, 1 here and the minus here. So we will take this as the lowest precedence. So when you find out the lowest precedence, that have to take place at the root. So this will be the root of your particular expression tree. Okay, so you have taken this minus, and before this you are going to consider as a left subtree, and after this minus symbol you are going to consider this as a right subtree. So you have to take x into y. This is the right side of the subtree, whereas your left subtree will be this whole expression. Okay, so we will write that. So a into b by c plus e by f into g plus k. So this whole a lot is going to be your left subtree. Okay, so this is a right subtree and this is going to be your left subtree. All right, clear with this? So again you have to find the lowest precedence. First you solve the left subtree, then you can come for the right subtree, or you can solve the right subtree first and then left subtree. It's just up to you. Okay, so first we will solve this left subtree because it is having so many the expression is very big. So we will solve this and then we can come to the right subtree. So what is our next step? So again we are following this same step. Find the lowest precedence to fit the next root of this particular subtree. Okay, so for this left and right node, we have this to be the root node. When you are going to elaborate this particular left subtree, you should again have some symbol here and start from there. Okay, so here we are going to see which is having the lowest precedence. So again you have multiplication, you have division, you have plus, you have multiplication, you have. So when you are seeing here, plus is having the lowest precedence, but we have two plus, we have one plus here and one plus symbol here. So obviously we will evaluate this first and this will be evaluated at the last. So we are taking this to be the lowest precedence. Okay, so what step did we follow? After finding the lowest precedence, we have to split the expression. Okay, so at this particular point, this plus symbol will be the node, and we are splitting the equation into two. So after the plus will be right and before plus will be left node. So here we are having, after plus we have k. One before this, the left, towards the left side you will have a into b by c plus e by f into g. Okay, the root for this is your plus. Okay, I have given the plus. Since I am not able to rub it and write again, I have given this particular root to be here. Okay, now we have to solve. Now we have to solve again this particular equation, because here we have ended up with the leaf. After this you cannot extend, you don't have any operator, you have ended with the operand. So this is one of the leaf. Okay, so now we will move here. Now again the same rule you have to follow. You are going to find the lowest precedence. So who is the lowest precedence here? This plus symbol. So you have only one plus symbol, where you will take this to be the node of this particular position. So here you are having plus, and before plus it has to split, and before plus you have to split here, and after plus you are going to split here. So we will split now. So this side you have E by F into G. This is one node, and towards the left node you have A into B by C. Okay, so your expression is divided now, and you have these two as a left node, right node. For this, what is the node? The plus symbol here. Okay, now again we are going to split this. We are going to see which is the lowest precedence. If you see here, you have only multiplication and division. Here multiplication and division have the same precedence. Okay, so you have to traverse from left to right. When you are traversing from left to right, first you will evaluate this multiplication and next you will go for this division. So we will take the symbol which we are evaluating last. So this will be evaluated last. After this only we are evaluating this. So this will be the last. So this particular node will take the division symbol. Okay. So before division symbol, whatever you have to put in one left node, and after division you are putting it in the right node. So after division you have only C. C has ended as an operator. So after this you cannot extend. Before this you have A into B. So you have A into B here. Okay. Now we have only one operator. Okay, we have only one operator. We cannot go choose for any other operators. It is given clearly. So this particular node will have the multiplication symbol. So left node, that is the left child, will be A and the right child will be B. So after this you cannot end. If you see, all the operands are at the leaf, and you have this multiplication symbol is there. So left node will be A, right node will be B. You have multiplication symbol here. Left node will be this particular equation. Right node has become an operand. So this side we have completely solved. After this you cannot extend. We have extended this. You had the whole lot of expression, you reduced it, you found out the least preference operator. Then after finding the least preference operator, that will be the node, that is the intermediate node. It will become the intermediate node. Towards the left side you are splitting up the equation after that, and right side. So again you have found out the least precedence. You have completed till this. Now we have to go for this expression, because this remains alone. This has to be solved. So here if you find the least operator, both has the same precedence, division and multiplication. So we are going to solve this first. When you are traversing from left to right, we are solving this first, and next will be this. So this we are going to take as the least precedence operator. So this particular node here, it will take the symbol multiplication, and here after multiplication what you have only G, and towards the left you have to write E by F. Now if you check for this particular equation, you have only one operator, E by F. So this particular node will take the division symbol here, and you have F as one side, right node, and E to be the left node. So after this you cannot extend. Here also you have only G. After this you cannot extend. So if you see here, after this you cannot extend. So this node is a leaf. After this you are not able to extend anything. You don't have any operator. So K if you see is an operand, and it's at the leaf. Here if you see, C is at the leaf. After this you are not able to extend. G if you see, after this you are not able to extend. All these are operands, and all the operands belong to leaf. Okay, so our first condition is satisfied, and operators are the intermediate nodes. If you see here, this is an intermediate node. Root is an intermediate node. You have a minus. Here again you have a plus, which is an intermediate node. You are having the left child and the right child. And here if you see, this is a plus is a intermediate node. You have a left child and a right child. So if you see, all the operators are coming at the intermediate nodes, whereas your leaf nodes are becoming operand. So our left subtree is solved now. Now we will move on to the right subtree. Here you have, the equation is simple. Only you have x into y. So this symbol will become multiplication, and you have the left node to be the x and right node to be y. So after this you cannot extend. So this particular expression is expressed in the form of an expression tree. This is an expression tree. So the output of this is what? How will you write? Eliminating all these equations and all. I have taken the symbol here. Okay, so we will write it up clearly here. So our expression tree is going to be minus at the root, and after that you had plus symbol here. Okay, this plus symbol we are having here, and this side you have a multiplication. This side you have an x and y. Here after plus you have again a plus here. Okay, I'm talking about this plus, and the right is k, this k. Okay, so from here we are extending, so this node again will become a division, this division. Okay, and right side is your, what did we have here? Multiplication here, and again you are having this multiplication here, and towards one side you have an operand, you have c, this c. Okay, and this multiplication again you have g towards one end, this g, and this is extending again. Okay, you have a division symbol, you have e and f. Okay, this e and f, sorry, this e and f. Okay, so you have a multiplication here. So this multiplication we have, I have put it here. Next you have a, and towards this you have the b. So this is an expression tree for this particular equation. If you see from here, a into b by c plus e by f into g, okay, plus k minus x into y. So this is how you have to solve a expression tree. If I give a equation like this, the first step is you are going to go check for the lowest precedence. First you are checking for the lowest precedence, and you have to traverse from left to right. Suppose you have an a power of symbol. In that case you have to traverse from right to left. So that will hold the highest precedence. In that case you have to traverse from right to left. Since you don't have a power of symbol here, you are moving to the next precedence, multiplication and division. So multiplication division means you have to traverse from left to right. Since we have the rules as all the operands should be leaves, we are going to start from down. So down, highest precedence are starting from down. So obviously your root will be the lowest precedence. Okay, so initially when you have to build a tree, first you have to find the lowest precedence operator, put it on the root. From there you have to split the equation as a left subtree and right subtree, and then again you have to follow the same rules. Again when you have a left subtree, again you find the lowest precedence from there, again you split it as left and right subtree, again you find the lowest precedence, from there you split it again until you have the operands at the leaf. You have to keep elaborating. Then after finishing with the left subtree, you go to the right subtree, you finish the equation till we have the operands. Operands means your alphabets. Okay, when you have the operands at the leaf nodes, you stop with that. Until then you have to keep extending the expression trees. So this you call it to be a binary expression tree. Understood? So if you have any doubts, you can mail me. Okay, since I cannot take the class live. Live means I cannot just work out. Okay, so I wanted to record this video and upload it for you to understand. Okay.